Math notes for section 121 are all about trigonomic relationships and triangle trigonometry. So this question is also, this type of concept is also needed for question number 60 in the review preview. So it's really important that you understand how to solve for a missing part of a triangle using trigonometry. So there are 3 trigonometric ratios you can use to solve for missing side lengths and angle measurements in any right triangle: tangent, sine, and cosine. In the triangle below, when the sides are described relative to the angle theta, the opposite leg y and the adjacent leg x, the hypotenuse is h, regardless of which acute angle is used. So if we wanted to use tangent, we would look at the opposite leg over the adjacent leg, and that's going to be equal to y over x. So if this is the angle that we're given and we were going to solve it by finding tangent, we would need to know the opposite leg over the adjacent leg to the angle, which is y over x. If we were using sine to figure it out, we would need to know the opposite leg, which is over here, y, over the hypotenuse. If we were using cosine to figure it out, we would be doing the adjacent leg over the hypotenuse. So the adjacent leg is x, the hypotenuse is h. So it all depends on what we were given in the problem to help us figure out what we're trying to do. In any general, for any uniquely determined triangle, missing side lengths and angle can be determined by using the laws of sines and the laws of cosines. So the sine of A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. And C squared is equal to A squared plus B squared minus 2A times B cosine of angle C. Okay, so let's do an example together. It's actually one of your homework problems. So say that we were trying to figure out what this problem was and trying to figure out the missing side. So we know that the angle is 15. We know that we have the opposite and the hypotenuse. So we have the opposite side and we have the hypotenuse. So we want to look, so opposite over hypotenuse. So we want to look back at our rules and say, okay, opposite leg over hypotenuse is sine. So we know that the sine of 15 degrees is going to be equal to the opposite length, which is x, over the hypotenuse of 20. So then what we would do is we would solve for x. So I'm going to multiply both sides by 20. And then I'm going to end up with these canceling out, and I'm going to get 20 times the sine of angle 15 degrees is equal to x. So then I put this into my calculator, and after I've put it into my calculator, I believe I get it to be about 5.18. So x is equal to approximately 5.18. It's in meters. Okay, and then you would use it. So if you, depending on what you're giving, so you always want to look at what you're giving in the triangle and then match it up to whether you're going to use sine, cosine, or tangent.